Okay. Hello, everyone. Thank you for coming. Before I start, how many of you have read The Hitchhiker's Guide to Galaxy? Oh, is that why you came for the talk? Because you saw Don't Panic on the title? Okay, so yeah, the Don't Panic is a reference from The Hitchhiker's Guide to Galaxy. I actually read it pretty recently. I stole it from my previous workplace, but it's being recorded, so I shouldn't say that. Um, okay, so let's hitchhike our way to building some secure GraphQL APIs then. A little bit about me before we get started. So my name is pronounced Meenakshi, but I just go by Meena. And I'm from India. That's how you can follow me on Twitter if you still haven't left Twitter, that is. Oh yeah, I'll try saying this. I hope that it means hello Norway, greetings from India, but I can't be sure because it goes wrong sometimes. So forgive me, I know I will botch this up, but hej Norge, hilsen fra India. Hey, okay, I'm trying. Okay. Yeah, so I work as a developer relations engineer at Postman. Postman is an API platform that you can use to build and test and use APIs. And yeah, I'm trying to learn Spanish since quite a few years. I always forget, have nobody to practice, then go back to zero again. And I like yoga and strength training. And that's a lot about me now. So before we jump on to discussing the security practices about GraphQL, let's just take a quick look at what GraphQL really is. So we go right back and we'll start with the GraphQL story. So in 2011, Facebook had begun to focus its efforts on mobile development, and the mobile apps, the mobile did not have access to reliable high bandwidth connections, and the Facebook engineering team needed to find a solution to improve the request latency between the mobile clients and the backend Facebook infrastructure. One cause for the latency was the recursive data fetching. So the news feed on the app, for the news feed, if a request was made to the backend, then the backend API would return the news feed, but for some other components, you would then have to make additional requests. So it resulted in the newsfeed being loaded partially on the phone or having a delayed loading time for the comments. And that's when GraphQL was designed. So in 2015, yeah, it's 15, GraphQL was designed to fill a need that arose when building Facebook's mobile apps. And they wanted a data fetching API which was powerful enough to describe all of Facebook, yet it was simple for the developers to learn and start using quickly. And the adoption grew because in 2016 is when GitHub made their GraphQL API publicly available. 2019 is actually when the GraphQL Foundation was established. So it helps ensure that the community is able to focus on the evolution of the spec and the implementations. So I've tried to take the NDC app as an example. These are screenshots of one is of the mobile client, the app, and the other one's of a web client. So now since they're both different clients, it's almost the same kind of information, but there might be some details that are shown on the web client and may not be shown on the mobile client. And if it's all served with a single API, then a client has to actually accept the entire response, use maybe just some of the fields, and probably just throw away the rest. So it's not as useful for them, and it does cause latency, which is why Facebook came up with GraphQL in the first place. GraphQL lets you specify exactly what you want to fetch. So you can use the same API, and unlike legacy APIs, you don't have to fetch tons of data. Even if like there's lots of fields that are there in the response just purely to maintain backward compatibility for some clients. But you can just pick up, as a front-end developer, I could just pick up only the fields or the data that I'm interested in, and leave out the rest. And so in a way, it kind of shifts the power into the hands of the front-end developers, because the front-end developers can say what exactly they want instead of asking the back-end developers to probably make a change, build a custom API, and then deploy it for their client. On the server side, how each of these are executed is they are parsed and validated, and the validation is performed against the types that are defined in the schema. So for this example, we've broken down the entire schema into the contact, a location, and the talk. And it's not just for querying, so you can also do like all kinds of CRUD operations, like there's mutations that you can do, as well as querying. And in addition, it also helps you represent relationships between the different pieces of data. So each entity in this, maybe the talk and the contact, are like nodes, and the edges are like the relationships that they have with each other. And that's the natural way that you think as well when you're actually designing your interfaces. Another important thing that is useful for, and this is one of the most common ways in which GraphQL is implemented. It's implemented as a gateway, and it can be used to connect multiple backends. So if it's a third party, if it's probably another service using GraphQL, it's built on top of your REST APIs and other microservices. It's all a unified interface to access data from the different sources. Which means that it could be a single entry point into the company's APIs. But it's useful in a way that in order to learn and to use it easily, it's helpful to understand how the pieces are connected. I think, there was this podcast where one of the engineers from meetup.com was actually sharing that GraphQL is helping them understand how each of their services are connected, and it gives more insight into the structure of the APIs that they have. Okay, so coming to the crux of the matter, we've looked at the history of GraphQL, what GraphQL is, and before we delve into security, again, we just need to know why it matters. Isn't it the same like securing other APIs? So one of the reasons that it matters is its increasing adoption. It's in a hyper-growth phase. And there's this Gartner quote that today just over 10% of enterprises were using GraphQL APIs in 2021. But by 2025, that number will grow to over 50%. At the same time, the data also, it continues to be a critical resource for companies, along with the preference for using mobile devices. So data and mobile clients are the use cases where the advantages of GraphQL are realized. There are combinations of API technologies as well, like we saw on the previous slide, that allow GraphQL to connect to different data sources. And so it's becoming the technology of choice when creating data and services inside an enterprise network. It's some also refer to it as the data layer. And these new API implementations, they create a sort of superstorm of security concerns. Yeah. Another one of the reasons is that it's newer than other API technologies like REST or gRPC, and it only became community-driven and broadly invested in after the GraphQL Foundation was created in 2019. One more thing to remember is that it doesn't leverage any of the capabilities of HTTP, and there is a lot of custom-made tooling to handle things like caching and security, but there still isn't any solution leaders in distributed systems or cache or security, like they haven't been determined as yet. Okay, so we established some ground, and if you still don't think that it's as important to secure your GraphQL APIs, yeah, actually, first part my job was to kind of make you panic. Yeah, so if you don't, yeah, if you don't kind of panic now, you're gonna be like the Scream. It's a painting, right? I'm supposed to go to the Munch Museum to check it out. Yeah. So yeah, you're going to be in like a panic state later. So just a little more information to scare you so that you probably listen in the latter half. Um, and this one's from March 2020. It's not too old. GitHub allowed an attacker to collect user information only because of missing authentication check for certain GraphQL queries. Okay, here's another one. WordPress has a GraphQL plugin, and it suffered from a denial of service attack because of an extremely expensive query. And another, it's Instagram. So this is from a bug bounty program, and the bounty hunter managed to find a vulnerable GraphQL endpoint that without a person actually following your profile, they can get access to all of the victim's private archived posts. So if you've made any reels about the conference, I would suggest just go back and check. Okay, so what I've tried to do here is I tried to do just a keyword search on the National Vulnerability Database to see the statistics for GraphQL. And it seems like the attackers have gotten slightly better from 2019. So we definitely need to get better at protecting our systems from the common attacks. And one of the many mistakes, again, was thinking that GraphQL APIs would have to be secured just like any other APIs. But there's this code by Tristan from Escape Technologies, which is also a security tool for GraphQL. And it's also a reminder that GraphQL is not just an API, but it's also a language. So the attack surface is much larger than that of other APIs. Yes, since I was doing a little digging into the vulnerability database, and I work at Postman, I just wanted to visualize to see if there's any parts that we should pay more attention to, find out like certain keywords, because there were a lot of entries of incidents that had happened. Yeah, and yeah, I made a word cloud. I may not have done an excellent job removing the noise from the word cloud, but there is words like authorization, authenticated, or information disclosure that you should pay attention to. Okay, enough talk. It's lunchtime, right? So I should yeah, I've been thinking it would be nice to use a little bit of Postman and have some demos to like keep you awake. So let me show you the example. Yes. Okay. So this is a word cloud that I made, and the collection for it is right here. And all of it and all of the content that I'm going to be using in the latter slides, it's all part of the GraphQL Security 101 public workspace. So you should be able to access it and be able to see all of the collections. I'm going to close this one. Yeah, so Postman actually had for a very long time an older version of the GraphQL client, and that's when I actually made this collection. So this one is a V1, but I also just wanted to show the new client and how it looks while we use it to send certain requests. So um, the collection is about the damn vulnerable GraphQL API, and that's a vulnerable implementation of the GraphQL API. It's an open source repository. I haven't created it. All credit goes to, again, I'm pronouncing their names wrong, but it's Dolev Farhi and Nick Alex. And they've also recently published a book about Black Hat GraphQL, which has a lot more about GraphQL security practices. So yeah, they're the people who we should be thanking for this GitHub repository, but it's a good way to try out the challenge and try and learn of different kinds of attacks. And that's what I've mostly done to understand what it's vulnerable to. So yeah, I probably should have mentioned there is this spoiler alert. Actually, it's a challenge. So you might want to break the API and then learn about what to do, what not to do. But this collection is to follow along. And if you actually want to just go to the solution page and understand what you should be careful of and not, then it's helpful to go along with the collection and do that. Yeah, so we will actually look at version 2. And before that, let me just try. Okay, so here's how we can start creating a new request. And I will actually create it from here. So there is, yep. So what I've done is I'm just locally running the vulnerable API. And yeah, so what it's trying to do is all of the types that are available in the schema are exposed through a feature called as introspection that is turned on for this API in this case. And Postman as a client is actually using that introspection to display this list of all of the types that exist and all of the operations that you can do on the API. So yep, we come to introspection. One of the ways of doing the introspection, again, is to use a client. You could use a graphical or Postman or any other client, which would then show you what's part of the schema and what's part of the API. Another way is you can query it yourself. So you can get all of the schema metadata. You can query for the types and the mutations that exist and all of the fields that exist as well. So yeah, in this case, for this API, there are queries, mutations, and subscriptions implemented. So the first thing I would probably start with for any other API is to understand what are the kind of operations that are there. And yeah. So most of the public APIs actually, quite a lot of them, like APIs would have querying, but they wouldn't maybe allow you to mutate the data. Another thing to look out for is the field suggestions. So among all of the queries that are there, there isn't one for the system. So if I actually go ahead and execute this query, it's going to be very kind, and it's going to tell me if I meant paste or pastes or system debug and system update. So even if like the introspection is blocked, you can't see the entire schema, but all of these field suggestions are then helpful to know what's on the schema. Yes. So okay, you can also like it's also susceptible to all of the other attacks, like server-side forgery, which you can use to abuse the functionality on the server, or like update any of the internal resources. Yeah, one of the common attacks and the ones that we saw when we were going through the list of like GitLab and WordPress was a lot of denial of service attacks for certain expensive queries. So the attacker can find out a query that takes really long or is a very expensive query and keep using that and then bog the server down of resources and cause a denial of service attack. I'm not, yeah, I won't execute it, otherwise I will have to spin it up again. Uh, so yeah, there's also batch query attack. So you find out that system update is probably the query that's going to take the longest and it's going to be very expensive. What you can do is also batch it up, so multiple attempts of doing the same thing, and that's another way to bring the server down. And then let's say they blocked batching, then you can also use aliases and try to bypass the block by then executing the operation multiple times. Yeah, this one I enjoy. This can happen with GraphQL because it's relationships and all of the data is actually related. So you can go into like a recursive relationship and multiple depths. I like to call this the old man of Darjeeling has just come to town. I'm not sure if I probably had it in school. So it goes like the old man of Darjeeling has just come to town. The wife of the old man of Darjeeling has just come to town. The dog of the wife of the old man of Darjeeling has just come to town. The tail of the dog of the wife of the old man of Darjeeling has just come to town. And there's probably like more levels of it. But yeah, that's how I kind of associate all of these in my head. So this is one of the most common attacks that the implementers need to be aware of, the deep recursion query attack. Yeah, it's also possible to actually duplicate the field multiple times. And yeah, I'm just going to go over them a bit quickly. Okay, this is the way of using circular fragments. So a fragment allows you to fetch only the data that you need to actually display for a component. So yeah, let's say I have an entire page on React, and I want to just like I want the component to just focus on specific data that the component needs to render. That's when you can use fragments. So it's also possible to actually use fragments with circular references to each other to cause a denial of service attack. Yeah, then if you do a denialist, if you deny permission to the API to a few users and allow the rest of them, it can be pretty risky. So it's always better to go with an allow list and block all of the other users that we don't know. Yeah, and it's susceptible to command execution. SQL injection is again the same because we're accepting inputs for queries or for mutations. So we need to be aware of all of the regular ways of injecting malicious code, whether it's a cross-site scripting attack or a SQL injection or an HTML injection. So, yep. Okay, so what we do about it is we kind of saw a little bit about the attacks, and I'm just going to share a few techniques how you can mitigate them, or what are some of the common ways or tools that you can use. Yeah, authentication was one of the common ones. And certain fields, even though they're protected against, they have authentication, but just because of the relationship that they share, their data gets exposed. So all of the paths need to actually be authenticated. And why it can be tricky is because at the back end, for every field that you mention in the query, there is a resolver function that executes. So what happens when you actually fetch the field or you mutate something? And if you try to add authentication to each of these resolvers separately, it may be a lot of duplication, and it may be too tightly coupled with the business logic and difficult to manage. So there is a middleware pattern that you can use to add authentication or any other functionality for that matter if you have common logic across multiple resolvers. And yeah, so when the client sends the request is validated against the type system, and then authentication can come in as part of the middleware, and the response can be returned. Yeah, another one was authorization. Who gets access to what actions they can perform on the system? So there's a couple of ways to do these by using role checks, by maintaining an allow list, and GraphQL Shield, which is being maintained by, it's open source, it's being maintained by the Guild, which also actually maintains a lot of other GraphQL tools that are open source. And Shield is a GraphQL library that can help you to create a permission layer for your server. So you'll be able to define the collection of rules that you can use across your permission system. Yeah, the favorite denial of service attacks. So the nested recursive query that we saw. And it's very easy to exploit resources using this. So what you can do is because of the depth of the query, there are actually libraries to help you do the max depth check to prevent these attacks and mitigate them. If you try to do this with the GitHub API, what it also does is it analyzes, let's say I'm asking for all of my pull requests for a certain repo, like all of the comments on each of my pull requests for a certain repository. What it's going to do is like just count the total number of nodes that I'm actually requesting for, and then limit my request or give a response that like I'm requesting for too many nodes. Yeah, the batch attack. One way is to disable batching. Another way is to protect your system by having rate limits in place. So now this isn't. It's not the number of times that you actually call the API, because here it's just a single API, but what actually differs is the payload that you're sending to the API. So there are different ways of doing a query cost analysis for each of the queries that are being executed against the server, and use that cost to rate limit. And there's different algorithms of doing it. There's a static query analysis as well. It can predict how expensive a query might be. And there's a dynamic query analysis, which can sum up the cost in the GraphQL execution engine as it's evaluating the query. So yeah, you don't only have to pick from among these two. Maybe you can use a combination of them for rate limiting or monetization as well. Yeah, so if batching is disabled, we looked at aliasing. One way to deal with them is you could use persisted queries. And this is a pretty common way of protecting and like limiting your attack surface. So persisted queries are actually used because typically with GraphQL, we can have like a really large payload that's coming in one request from the client. And the result, it can result into longer request times because of the payload being so large and slow down the network performance. So persisted queries help with this. What you can do is you don't have to, for each request, put the entire payload. The server can register, or the entire payload or server can register the queries that you're actually going to be executing against it with an associated hash. And as the client, I would just have to provide the hash for the particular query, and thereby like the payload is significantly reduced, and the query will execute. So that's how it's helpful. Like it'll help reduce the payload. But in terms of security, it's also helpful because now you can only allow the clients that actually have the hash to execute the queries. You can limit it from accepting queries from other clients. Yeah, the introspection that reveals the entire schema, it's very useful while debugging or while developing. And yeah, it's an important feature, especially for the developers when they're using a new GraphQL API. But if it's to prevent it from attacks, you can disable it on higher environments or on production. And similar for the error suggestions, there is a way to disable field suggestions as well, if you do not want to, which you might not want to expose the information to attackers. Yes, so don't think we have covered what custom scalars are. So a custom scalar type, it provides a convenient way to represent specialized data. There are built-in types in GraphQL, like integers or floats, booleans, but they don't cover other custom formats like an email address or a date time. So those formats can be represented as custom scalars. In this example, we have a scalar email address, and there is a mutation that's accepting input as the email address. Yeah, so since we're just declaring it as a scalar, but we've actually not done any validations on it, again, it's susceptible to injections or cross-site scripting attacks. So whenever we're using custom scalars, it's very important to sanitize the input, use validation techniques to prevent potential attacks. Yep, we're close to the end. I'm pretty sure I finished before time. But this is from the State of GraphQL 2022 survey. And over, I think, 3,000 developers took part in this. So, and this is specifically for like the security and the performance features. We've looked at persisted queries, I think query timeouts, rate limiting, depth limiting. The cost analysis is something that we spoke about, as well as disabling introspection and requiring authentication and allow listing. So this it is helpful to give a broad overview of the awareness that is there about each of these techniques and about how many people are actually using it in production. And yeah, for persisted queries, there's just about 20.5% of the responders who are actually using it. Disabling introspection is a faster thing to do, a quicker thing to do, and it's it's known as well, and a big percentage of people actually using it. What is so there's query rate limiting and depth limiting, which a lot of people know about, and maybe around 26% of the people are actually using it in production. So, think I'm going to be closing now. I will leave you all early. But yes, it takes 20 years to build a reputation and a few minutes of cyber incident to ruin it. Yeah, this is actually from one of my favorite TV series. It's called Arrested Development. Yeah, and every time there's something wrong, the characters are always like, I made a huge mistake. So yeah, if you're actually calling somebody to say that about your GraphQL APIs, it's too late already. Before I end, Postman is also a member of the GraphQL Foundation. And this year, the GraphQL Conf is going to be hosted by the GraphQL Foundation. That's in September. Postman's a part of the foundation, and we're also a sponsor for the conference. So I'm actually getting to help with a lot of the organizing as well. But if any of you work with GraphQL are interested in sharing your learnings, the CFP is still open. I think it's open for another 2 weeks. And we're also doing some cool live streams leading up to the conference. So if you're interested, you might want to follow the GraphQL page on LinkedIn and join in on the action. Yeah, this is a couple of resources that I use for the talk. So there's this great talk by Christina about introduction to GraphQL security. And the damn vulnerable GraphQL application that I used, just for an introduction to be familiar, I just encourage everybody to try it out. And yeah, the GraphQL security public workspace you would be able to access. And this one's actually a very important article, the one about the whys of GraphQL security. And yeah, my boss has actually written it, so I use a little bit of it in the presentation. But thank you.